I buy him a sub, it's all good. So, I didn't think of borrowing someone's car. Like that's a great idea.
You have to give us a Mr. Up car review. Drive it like you own it.
Oh.
Yeah, drive it like you own it.
Well, I only have to drive it down Lake Winkler, so it's not very far. I have to drive it. Okay.
For the drive-through Subway.
I just ordered on the app and then I'll just pick it up.
Oh, I've heard bad things about that place.
Why? I've got subs there many times. Okay. So yesterday we ended up with molarity. And how are we going to do molarity? We talked about net ionic equations. So we're going to do a basic one, something kind of like what we did last chapter, and then I'm going to show you the full shebang of what you have to do on one of these for this chapter. So start out with this. Start out with 24.3 milliliters of 0.200 molar lead 2 nitrate reacts with 36.7 milliliters of 0.250 molar sodium iodide. ... I would want to know how much lead 2 iodide is formed in grams. How much lead 2 iodide is formed in grams? I got a little fan for my room. I found it on the clearance at Walmart yesterday, $10. It really helps. It like moves the air a little bit. Yeah, keeps me cool. Yeah, I get overheated up here. It's just like, yeah, it's a win. It's a win. Step 1's gonna be what?
Oh, write a balanced equation.
Write a balanced equation. So lead 2 nitrate. Lead 2 nitrate. I have PbNO3. What's going to be after my parentheses there? 2. Because NO3 is a 2. All right. AQ or not? AQ?
No.
L? You tell me. I'd get out your rules.
It's not because it's not. Notable exceptions are salts containing the ions Ag plus Pb2 plus and Hg.
But look at number 1.
Most night.
This is nitrate salt.
Does it go in order of importance? That list?
Yes.
Okay.
That's aqueous.
That's. I don't
Plus
like it.
sodium iodide, NaI. That is also AQ. Also AQ. Is going to give me, I know one of the things that's going to give me, I told you, is lead 2 iodide, right? So PbI2. Solid, liquid, AQ.
Probably not aqueous.
No.
Solid.
Solid, why?
It's not
Which rule is
It's a precipitate place.
that? Rule number 3. How do we know?
Most chloride, bromide, and iodide salts are soluble. Notable exceptions are ions containing Ag, lead 2, Ag2. So I'm going to say, you can either say solid. I like to draw an arrow down instead of solid. It's kind of the same thing, so I know that's my precipitate. Yes,
When it's not aqueous, how do you know if it's a solid or a liquid?
it's either a solid or it's water. So water is going to be the only thing that's a liquid. So it's going to be solid. Good question. Plus, what is my other product going to be? NaNO3. NaNO3, which is going to be AQ. Okay, step 1 done. Step 2. Balance. Balance. Where am I going to put some coefficients?
In front of that area.
Private NA.
2 here,
Yes.
2 here.
Yes.
That look good?
Yes.
Okay. And I like to write out what I'm given. So I have 24.3 milliliters of this, which is also 0.200 molar. And I was also given 36.7 milliliters of this, which is 0.250 molar. I want to know how many grams of that. So that's kind of setting up my problem. What am I going to have to do to figure out grams of lead-2 iodide? What am I going to have to do in that stoic? How am I going to determine which one? What am I going to have to figure out? Eliminate reactant. I have to figure out which one's eliminate reactant to get my actual yield, right?
So like same thing we did last chapter.
Same thing we did last chapter, but with molarity. So here's how I would start this. I would start out with my 24.3 milliliters of PbNO3 parentheses 2. Do milliliters help me? No, because my molarity is in what? Moles per liter. So I need to convert this to liters first. So I can say that there is 1,000 milliliters of PbNO3 parentheses 2 in 1 liter of PbNO3 parentheses 2. Okay, now, super easy, because now I can use my molarity, right? Molarity is what? Moles per 1 liter. So I know for every 1 liter of PbNO3 parentheses 2, I have how many moles? 0.2. You got it. I have 0.200 moles of PbNO3 parentheses 2. So, very similar to last chapter, but now we're just using molarity as a way to get it to moles.
Instead of
Just grams. Instead of just grams. Solve that. Tell me what you get. I love that you guys have real calculators. Makes me so happy.
This thing has been okay.
4.86 times 10 to the negative.
That's not going to be super helpful for figuring out.
You're wrong.
Actually, I don't think that's
You're
right.
wrong.
Hold up.
It's 0.00486.
Yeah, you're going to want a decimal answer. 0.00486
I don't know.
moles
No, neither. I got it.
of PbNO3 parentheses 2. Okay, so that's my first one. Second one, I don't care how you guys want to do this. If you want to go liters 1,000 to 1, you can. If you want to do it in your head, I'm okay with you just starting with liters. So just move the decimal 3. If you trust yourself, 0.03. Maybe you don't trust yourself. If you don't trust yourself, then do it to liters first. But I'm not going to show that. Okay? I'm not going to show that because I can do that in my head. I know that 36.7 milliliters is 0.0367 liters of NaI. However you want to do it in your work, I'm okay with it. Because if I start with liters, then I'm only have to really do one step. Because every 1 liter of NaI is how many moles? 0.250. 0.250 moles of NaI from the molarity. Solve for moles of NaI.
Oh, got it before you know.
I need to see if Subway is open early enough for my lunch.
They definitely are. Wait, what? Lunch yet? I think 4 is the word for that.
I serve breakfast too, so they should be.
That's trash.
I know.
That's
Does Subway serve breakfast?
yes.
Yeah.
Subway, eat fresh.
To pull it on top.
Real.
Says it's open.
8,000 points.
Says it's open. What'd you guys get?
Oh, 9 was the butt.
0.00918 moles of NaI. I know, for every 1 mole of this, how many moles of NaI do I need?
2.
So I need double of this for here. I need double of this for here. Do I have double of this here?
No.
No. So this is my LR. That's my limiting reactant. So now I'm going to run my moles, 2 grams, and I'll be done. So 0.00918 moles of NaI. And stoichiometric step, for every 2 moles of NaI, I have 1 mole of PbI2. 1 mole of PbI2 is going to be massive because those are both massive molecules. From your sheet is 461.008 grams of PbI2. That will give you grams of PbI2. So similar, what'd you say? 461.008. 461.008. What'd you get?
Very good, before I say it.
Brady, what'd you get?
2.12.
That's what I got. I got 2.12 grams of PbI2. So that's kind of like the beginning step for what we're going to be doing, like the whole shebang. So that's not the whole shebang for this chapter. The other thing that I wanted to show you was a little equation when you are diluting solutions. All right? For dilute solutions, you're going to be using this equation a lot. M1V1 equals M2V2. M1V1 equals M2V2. What? Molarity of one, molarity of the first thing times the volume of the first thing equals molarity of the second thing times the volume of the second thing. So you can see a problem where they're like, the molarity of a substance is 0.50 molar at 30 milliliters. If I dilute it to 0.7 molar, how many liters would it take? And you just solve for the one you don't know. Pretty easy. So sometimes you just have to do this and not all of this. But guess what? You can also get it by doing all of this. So watch out for an M1V1, M2V2, okay? It's almost like you'll think you have to do this, and you could do it with this, but you can really just do like with this. It's almost like I would do that to you on a test, you know?
Is it like the law of conservation of molarity? Is that a thing?
No,
Can I invent it as a thing?
no, it's just proportions. Yep. And this is exactly what we do when I'm making up your chemicals, right? So when I'm making up, if I need a set of known molarity of hydrochloric acid, I'm basing it off of 1 liter, right? And then I figure out, well, I need to make this many liters of this molar. That's what we do. Exactly what we do. Look at that, practical application, Mr. Worth.
I know, I love it.
Yeah. So that's exactly what we do when we're making our stuff.
Thinking Barrow did it last
Yeah, pretty cool.
year. It's very useful.
How small can you write? Because what I'm about to do is going to take a whole page of work.
No, take half a page.
Okay. All right, it's up to you. It's up to you. It's up to you. All right.
Like, can you go like half on one page?
Yeah, I just like to see it all on one page, but you don't have to. 17.36 milliliters of 0.250 molar lead 2 nitrate reacts with 47.61 milliliters of 0.175 molar sodium sulfate. There's my setup. Here's what I'm going to ask you. These 2 little questions is going to be a whole page worth of work. Question 1. I can't wait to see Jawwe's work. How many grams of precipitate are formed? We just did that. Question 2 is, what is the concentration? Many times you will see brackets for concentration, or we can write out concentration. I'll write out concentration as well. What is the concentration of all remaining ions? What is the concentration of all remaining ions?
Oh my god.
You can take 3 minutes and do the first part.
Oh my god.
might be more than 3 minutes.
Anyways.
Sheet out. What does the second thing say?
What is the concentration of all remaining ions? So part 1 we just did. And now you're going to start to see why we run stuff to moles for our limiting reactant. It's just going to save us a lot of work for the second part. It's kind of cool because we are just building on what we did last chapter. I'll give you guys a 5-minute head start. You'll notice you're starting to memorize some of these ions, like nitrate. You probably know NO3 is a -1 already. All right? Because you're using it all the time. And you're just going to, through use, start remembering some of these things. Sodium sulfate. You might already know that SO4 is a 2-. So these things we're going to be using over and over and over. Step 1, write the balanced equation. I was really hoping someone was going to bring snacks today.
I'm sorry. I have a granola bar in my pocket. Yeah.
Do you guys like flatbread at Subway?
Everything falls out. Does that make sense?
Yeah, I get it. Also, if you haven't done the AP classroom questions, today's the last day if you want full credit.
Did you see my email?
Yes, today.
Did I bounce that?
Why did I do that? I'm going straight to liters. That's dumb.
Why not? Yeah, I just go straight to liters. I just move the decimal 3 to the left. If you don't trust yourself, that's okay. So I have lead 2 nitrate. That is PP. Sodium sulfate. Yes. PP. I'm going to do a check step. I have my balanced equation up there. Doesn't matter. Does not matter where you write your precipitate. It can be first or second. The order does not matter. gets annoying having to write out those formulas, but you got to do it. You just lose track of what you're doing if you don't.
Jack last year. Last year.
What'd you say?
What?
I said Jack last year again.
What about it?
You forgot to write the formulas all the time.
Like in your stoic?
Yeah.
Oh yeah, never.
Yeah.
Also no units.
Yeah, Jack was just crazy.
I was a rebel.
Is that what we're calling it? Oh my.
Whoa.
Stop breaking this social.
Not 0.004.
Yeah.
0.0.
Okay, no, you can.
761 meters.
Stop writing so you know me. Oh. Jack, what's your record yourself?
Pushing B. Pushing B.
One to one, right? So limiting reactant is this. Okay. So I'm going to take that, and I'm going to take that and make that my 0.00434 moles of PbNO3 parentheses 2. Stoic step, for every 1 mole of PbNO3 parentheses 2, I have, I'm trying to figure out PbSO4, right?
Okay, this is what I was confused on. How do we know what we're running into?
Because you can't get grams, right? It says how many grams of precipitate. So I'm running it to the precipitate.
Oh, I see.
Okay?
Okay, there, pop it.
Is 1 mole of PbSO4. 1 mole PbSO4, good question. And 1 mole of PbSO4 is 303.262. Is that what you guys got? 303.262 grams PbSO4. So that gave me 1.32 grams PbSO4. Part 1 done. Questions? Questions on part 1. Part 2. What is the concentration of all remaining ions? Any guesses of what we're going to have to do here?
Break it up into
Net ionic equation. You got it. So I'm going to write my equation again down here just so I can see it a little bit better. So PbNO3 2AQ plus Na2SO4 AQ yields 2 NaNO3 AQ plus PbSO4 precipitate. Okay, so let's do the net ionic equation. We know that all of these are going to break up, right? Yes?
Yes.
They're all aqueous. I have no acids or bases to worry about, yes?
Yes.
So let's break this up. I have Pb plus 2. Agreed?
Yes.
Starting to break it up now. Plus what? How many NO3?
Oh.
Plus 2
Okay, maybe.
NO3 minus. Does that make sense? Because there's a subscript 2 on the NO3. You guys good with that? Plus what? 2 Na plus SO4 2 minus. Are you okay with that so far? Maggie, you good? Okay. Yields. How many NAs? 2 Na plus 2 NO3 minus, because that 2 distributes, plus PbSO4, which is my solid. So let's talk remaining ions. Well, first of all, what's my limiting reactant? PbNO3. So this is my limiting reactant. Yes? So this is my true limiting reactant. This is the limiting ion of the equation.
Specifically the what?
Yes, specifically lead. How do I know? Because, what's this? NO3. What is NO3 minus? It's a spectator ion. So even though it's part of PbNO3 too, it's a spectator. So the lead 2 ion is the true limiting ion of the equation. Kind of cool. Kind of cool. Would you be asked that? No, but it's true. 2Na plus is a spectator ion. Agreed? Yes. And SO42 minus is what? If it's not the limiting reactant, this is going to be my what? Excess. That's going to be my excess. So I'm going to have remaining ions of anything that's spectator. Agreed?
Yeah.
And my excess. So I have 3 ions I have to determine the concentration for. Head nod if that makes sense. I have to figure out concentration of nitrate, concentration of sodium, and concentration of sulfate. Cool? Molarity. Molar. So I know that molarity is equal to number of moles per liter. Agreed? You only have to write that one time, okay? I don't want you need to write that out all 3 times. So let's do what do you guys want to do first? NO3. So let's do molarity of NO3. NO3 minus. So that's going to be equal to how many moles of NO3 minus do I have? Come up here. This is why we do this. This is why we do this. I have 0.00434 moles times, take a look. This is the compound, but how many moles of NO3 do I have?
2.
Times 2. Times 2. Over. What's my liters going to be? And
Oh, we have, 0.01736 liters.
What did I do up here? What did I do to these 2 things? I combined them.
Oh, so you said the.
So I need the total liters.
Oh!
Which means I have to add this plus this, right? I have to add those together to get, I add those up to get my total liters. So 0.01736 plus 0.04761. So now you kind of see why it's kind of nice not to do that step. Does that make sense? To start with liters?
Yeah.
It's just, because then it's just easier. You can still get it. It's just like a less step. So when you add those up, you should get 0.06497 liters. Does that make sense for what I just did right there? It's a lot, but it's all there. It's all there. So you solve that, and what'd you get? .134 molar NO3 minus. First remaining ion, check. First remaining ion, check. Do it for the second remaining ion. Do it for Na. Try that on your own. Same setup. The nice thing is you already have your total. Same total. It's kind of fun. can also see why I said to make this all on one page. Is Jawway still on the same half page?
Yeah,
Yeah.
he's writing
How much space does he have left?
size 5.
Still have half. Like magnify.
What'd you guys get? I had 0.256. 0.256 molar Na plus. So once again, same idea. So my Na, I get my moles from my compound up here, but I've got 2, right? I have 2 moles of Na in that compound. Yes? Divided by the total, 0.256. Last one's the one that takes some extra work. Because on the last one, I have to figure out excess. Yes? In order to figure out excess, first I have to figure out how many moles were used. You got it. So you can see how we are literally combining everything so far into this. So I have to figure out moles used. So I have to start out with what? My limiting reactant, right? Yes? So I'm going to start out with my 0.00434 moles of PbNO3 parentheses 2. I have to run this to moles of what? The other one, right? So, Stoich step, for every 1 mole of PbNO3 2, I have 1 mole of Na2SO4. You see it? Is there any math I have to do here? It's a 1-to-1, right? So that means that I have 0.00434 moles of Na2SO4 used. 0.00434 moles of Na2SO4 used. Now what do I have to do? Subtract. So my start was what? What did I start with? Right here. Yep. 0.008337 moles minus the used 0.00434 moles used will give you your excess moles of Na2SO4. What do you get when you subtract that? What?
0.00.
0.0039 what? 7
Created that.
moles of Na2SO4 excess. Molarity of SO4 2 minus is equal to,
Go ahead, keep doing your thing.
is equal to my moles, right? Do I have to double anything here? There's only 1 mole of SO4. So 0.00397 moles divided by still the same total. 0.06497 liters. And now we have done it.
That was it?
Wow.
That was so easy. Why do you even bother teaching them this? They don't just know that?
I know. It just seems like they should.
Yeah.
What'd you guys get?
0.061.
That's what I had. 0.0614, if you want to, molar SO4 2 minus. And that is the concentration of all remaining ions. Literally everything. So that was 2 problems for the whole day. All right?
So on a test, we only have to do like 1 of those?
Oh, yeah.
Okay.
Only have to do 1 of those on a test.
What are we doing? How many points? Are we doing
Okay.
like point? I mean, that's gonna get out
1,
of
1,
control.
1, 1.
Okay. 1, 1, 1, 1, 1. I always make them do density average density.
Yep.
I add to this.
That's fine. 5. 5. 1.
4. No sig digs for slope because there's no measurements.
Okay. Fine.
Okay.
I think it's usually around 25 for me, is what I usually have.
So
We're done, by the way. 0.0